Hi everyone, this is our second lesson for ECE Discrete. This one goes along with section 1.2 and is for a new kind of election, one that may be familiar to you in other contexts, but is not one that you've probably seen highlighted in terms of an actual, like, decidable election. So this will be a bit new, yet you might see some familiar things in it. Okay, this will be called the Borda election. And let's take a look. Okay, so here's the idea. Up until this point, we have used, so far we've used plurality and runoff types of elections. And those have their benefits and their disadvantages. um, One of the benefits of using a runoff system, as we've seen before, is that we can rely on a person's second choice in order to force a majority. Well, we can kind of do the same thing here. So in this particular situation, though, what Borda's method is going to do is kind of generalize that and bring in a combination of people's not just second choices, but also third choices and more. Um, so the power here is going to be looking at the sum quantity of second place votes, third place votes, or more, and seeing if there are candidates that have significant amounts of those second and third place votes. And if they do, um, then they may be a preferred candidate, um, even to one that has more first place votes. Okay. Um, so one of the issues that arises in the plurality vote is when many choices are available and the winner has a small fraction of votes. So this is that Georgia runoff example where like the winner only has 19% of the votes. Um, so a runoff could be one way to determine, like, to get people to vote for another person. Um, but sometimes if we have the ranked choices, as they do in Maine, we can somewhat see that beforehand. Um, but this is another way that we can deal with it. And what's unique about this one is here we're not looking at majorities or pluralities or anything. What we're going to do is quantitatively assign a score, um, to a to all the different voters that can happen. Okay, so here's how it works. Voters will rank the entire list of candidates in order of preference from first to last. In other words, this part here, this is going to be a ranked choice. So remember here, ranked choice. So really, we're going to do a ranked choice ballot, but how we score it is going to be different. On every ballot, the lowest ranked candidate gets 1 point, next to last gets 2 points, and then further all the way up to the top choice gets n points equal to the number of candidates. The number given each candidate is summed across all ballots and the highest total wins. So this is the main Bordas method, the main version of it. So what this essentially is doing is allowing every choice on every ballot to have some impact. Um, and that's powerful, rather than only looking at first choices, second choices, things like that. This takes a lot of things into account. Okay, now this can get a little bit wacky, right? So picture this. Suppose that on a ballot, right? Let's say we go back and we do our strawberry, our vanilla, and our chocolate, and our mint chocolate chip, right? And let's say we have those again. And let's say we said in order 1, 2, 3, 4. So let's say that strawberry was ranked as the number one choice, vanilla was the number two, chocolate number three, and mint chocolate chip was the fourth choice. I'm just throwing this out there. This is not my personal preference. Actually, I would flip strawberry and vanilla, but I'm more of a vanilla person. But anyway, in this particular case, a person votes this way. What this is saying in a Borda's method is that the lowest ranked candidate gets 1 point all the way to the top, which would get, in this case, 4. So 1, 2, 3, 4. So you can kind of see the problem that you might have there, because then you'd have to do this on every single ballot and then add up all the numbers. That can be extraordinarily time consuming. Okay, but there's a couple ways that we can shorten this process a little bit. Okay, okay. Another equivalent formation is give the last candidate 0 points all the way up to the next to give some 1 point all the way up to n minus 1. So for that, that would be going back here, and instead we would give 0, 1, 2, 3. Okay, so we could do that. Now that's even possibly even more confusing than this one. So again, that one is also not very wieldy. Okay. Okay. The other equivalent for formulation: give the top choice 1 point since they are in first place. The second choice gets 2 points for second place, and so on and so forth. And this time, the lowest score will win. This is by far the easiest way to do it. Now, again, it doesn't matter which way it works, because whichever formulation you use, they will always agree on the winner at the end. You won't have any problems there. What you're just looking for is the ease of use. Now, again, most electoral commissions will have they'll have some sort of electronic system that will do all this automatically for those people that use Borda elections. I haven't actually looked this up. I am not aware of any municipality or any major outlet like a state level election or anything that uses this particular kind of election. It is entirely possible that they do this in small local elections, especially in small towns. But I don't foresee this happening in any sort of major municipality. Okay, so we'll see. We'll see what happens. All right. So here's a sample of how this is going to work. So we have 5 voters that are voting for a particular person, maybe, you know, voting for a group leader or something like that. We have Coleman, we have Horowitz, and we have Taylor. The question here is, in a Borda election, who wins? Okay, keep in mind, I want you to look very carefully at the top. Recognize that there is one group in which there are 2 voters. There are 2 voters that have this particular ranked choice of Horowitz first, Coleman second, and Taylor third. So in a Borda election, who wins? So remember what I said before, the default way that we're going to do this, because it's the easiest, is we are going to simply add up all the different place values. And when we do that, the lowest score is going to be the one that wins the election, because it will represent the lowest average voted place. So let's add it up. Let's start with Coleman. Okay, so Coleman gets 1 plus, now there's a 2 here, but don't forget 2 people voted that. So we're actually going to multiply 2 times 2. That's going to give us 4 plus 2 plus 3. And we're going to add that all up, and Coleman gets 10 points. Horowitz will do the same thing. For Horowitz, we're going to do 2 plus, now 2 times 1 here, because 2 voters put them in first place, plus 3 plus 2. And in this particular case, we're going to get 3, 5, 7, 9 points. So Horowitz would have 9 points. Taylor here is going to be put 3. Now 3 times 2 is 6. plus 1 plus 1. 9, 10, 11 points. So Taylor will get 11 points. Fantastic. So when this happens now, lowest score wins. So in this particular case, Horowitz. Horowitz is declared the winner. The winner with 9 points. Okay, fantastic. If you were to do this the other way around, if you were to assign 3 points for a first place finish and so on and so forth, the only difference that's going to happen here is that Taylor and Horowitz, the 11 and 9, are going to switch. Coleman will actually still end up with 10, and Horowitz and Taylor will just end up with 11 and 9, just reversed. And in that case, Horowitz would still win, but with the 11 rather than the 9. So again, here it does not matter. Now, an interesting situation here is, again, take a look at this data very carefully. All right, and let's look at the beginning. In a plurality vote. In a plurality vote, who would win? Nobody. Taylor would have 2 votes. Horowitz would have 2. Coleman would have 1. There'd be a tie. Okay. When there's a tie, they would go to a runoff. And in the runoff, Coleman would be eliminated. And those voters, or that single voter, they would go to their second choice, and that would be Horowitz. So in a runoff, Horowitz would win. So in this particular case, if we did a runoff, Horowitz would win. And in a Borda election, if we contested this under Borda's rules, Horowitz would win there too. So again, that agrees. But remember what I've said earlier on in passing. Is that these different criteria sometimes do give different results, especially if the votes are close enough. The reason being is that here we are tabulating everybody's second and third place votes instead of just those that matter. So in a runoff, everybody who votes first, like those get to stay. The only second place that matters is that one voter who swaps from Coleman to Horowitz. That's the only one that counts. In a Borda election, all the numbers count in some way, shape, and form. So it is possible that with enough votes, another candidate could take over. And I'm going to show you a case of that happening. Okay. So here's the situation. Again, we have ice cream, because why not? We're going to vote on ice cream, and this time we'll make a simple election between chocolate, vanilla, and strawberry. Okay, and so what will happen here is that we will take a look at the voters just like before and tabulate all the results. So we're going to do this the same way that we did in class. We're going to approach this particular data from one election type at a time. So we always start with a plurality. Okay, so let's start with plurality. So I'll write that down here. So plurality. My question might be, who would win in a plurality here? So in this particular case, we have strawberry has 27 plus 7, so 34% of the vote. These groups, they differ on second and third place for chocolate and vanilla, but they are 34% for strawberry. These two groups both voted first for vanilla, that's 30%. And here, 36% for chocolate. So chocolate wins 36%. Now, do notice that it is actually very close. 36, 30, and 34. And so because of that, when you notice that in the plurality vote that it seems to break down somewhat evenly, then you might wonder if you could declare a different winner in a different way. Let's look at a runoff. Okay, does this qualify as a runoff? Yes, not a majority. Okay, runoff, who gets eliminated? Vanilla goes. 30% is the least. Okay, as we said before, chocolate, chocolate, strawberry, strawberry. So the people who voted for chocolate, who voted for strawberry, they'll keep their votes. What's going to happen to the vanilla voters? Okay, all of these voters, because vanilla is the only one being eliminated, they're going to go to their second place vote. So remember, each column, you circle the lowest remaining number here. These 10% voters, they'll switch to chocolate. These 20%, they'll switch to strawberry. So who's going to win? Let's see. 7 plus 27 is 34, plus 20 is 54. Strawberry is going to have 54, 33, 43, 46. Chocolate gets 46. So guess what? Strawberry. 54% of the vote. So here's the case for the first time. You're seeing an election in which the runoff winner is different than the plurality winner. But do you see why? It's because of the fact that strawberry has an extremely large second place vote. The amount of people that swap to strawberry is far larger than the people that swap to chocolate. So it's able to overtake chocolate in terms of second place votes. Okay, the next thing that we're going to look at then is a Borda count. So in particular, I want you to keep in mind that one of the things, again, with a runoff is we're only looking at the second place votes of the ones that need to switch instead of everybody's second place. I want you to look very carefully at this chart. And I want you to look where all the second place votes are. Okay? You know, chocolate's got some here and here. Strawberry's got some here and here. But look at vanilla. 33 and 27. So vanilla's got 30% of the votes, but look at how many second place votes it has. And so that's going to be pretty interesting to see what happens. So once again, what we're going to do is we're just going to add up all the place values. Because we have a certain group of voters in each category, you just simply have to multiply these together and add them all up. So you're going to do 33 plus 3, that's 36. Plus 20, that's 56. Plus 60, 116. Plus 14, that's 130. And 130 plus, 130 plus, what is that, 81? That is going to be 211. So guess what? 211 points for chocolate. And you'll see that on the next slide as well. So again, I just multiplied the place by the number of voters in that column and added it all up. Okay, so chocolate gets 211 points. Let's do strawberry. 33 times 3 is 99. Okay, I'm going to switch to a thinner ink here just so that we can see this a little bit easier. Okay, so it's 99. 99 and 6, that's 105. 30, let's see, so this will be 47 and 27. So let's add all these up. 105, 135, 175. 175 plus 7 is 182, 202, 209. 209 points. Now let's add all these up. 6, so here's 9, 10, 20, 21, and 54. So again, I'm just multiplying each of these numbers by the number of voters. 66, 76, 96, plus 9 is 105. 105, 126, 176, 180. So who wins? Vanilla. With 180 points. And the reason why that vanilla wins a Borda's count is, yes, it doesn't have a large group. It has the smallest overall group of first place votes, but there's an enormous amount of the population that has it as a second place vote. So one of the things to think about here, again, as a third place, only 10% of people put vanilla in third place. So 90% of the voters had vanilla as either first or second place. So when that happens, you can believe that, 90%, approximately, now again, we don't know the exact number because second place may be good or may not be good, depends on the person, right? But 90% of people approximately are okay with vanilla, and that's really powerful. But also, take a look. 3 different election types, 3 different winners. So this is something that we really watch for in elections, especially with really close races. We like to look at all 3 of these and see, well, which one seems to fit the descriptions of like what people are going to be looking for in their choices. So, whether or not, first choice is good enough, or, whether or not people still like their second choice, things like that. So these are several, options that can happen. Okay. So Borda's count, and here's the rest of it here. You can see, right, we got the numbers all correct. So strawberry won the runoff, vanilla won Borda's count, and chocolate won the plurality. Yeah, so again, there's no guarantee that any of these election models will agree, again, especially if the data is close enough. Okay. So now, one thing, remember, that you don't want to do is to choose the election type after everybody votes. That is major fraud. Yeah, don't do that. Election type has to be, done beforehand so that the voting public knows exactly what system is going to be used. And especially you'll need to prepare the ballots beforehand. So knowing like whether you need people's choices or not, certainly important. Okay. All right. So we went over how it's all calculated. It's not that bad. Once you do a few practice problems of it, it kind of flows. That's why I like doing this way. The one thing again that you keep in mind, lowest score wins with Borda. Okay, lowest score wins. This is the only election type in which lowest score wins. All the other ones, it's highest score. So the one thing you're going to have to keep in mind. Okay, folks? All right. That's it, I think, for me. We've reached the end of our notes, and that's all we need to do here. So have yourself a good night, and see you later. Don't forget to hit that subscribe button. Yeah, okay. I'm not that good at that. All right. Have fun, folks.